Hello students, my name is Dr. Shreyanshu Singh. I am working as an assistant professor at the School of Management, BBD University. Now I am going to teach you Skewness, the topic of business statistics. Skewness is a very important characteristic of frequency distribution. Skewness means lack of symmetry or departure from symmetry of a distribution. In other words, we can say if the frequency curve of a distribution is not symmetrical, the distribution is said to be skewed or to have skewness. If the frequency curve of a distribution has a longer tail to the right of the central maximum than to the left, the distribution is said to be skewed to the right or to have positive skewness. We can see the positive skewness in figure A in upcoming slide. If the frequency curve has a longer tail to the left of the central maximum than to the right, the distribution is said to be skewed to the left or to have negative skewness. We can see the negative skewness in figure B. So now let's see the figure of symmetric curve. Symmetric curve means normal curve. The curve that is in bell shape. Symmetric curve uh, in symmetric curve, mean, median, mode all will coincide at single point. Now let's see the images of positive skewness and negative skewness. So in figure A, we can see the picture of positive skewness, and figure B, we can see the picture of negative skewness. As we know, for symmetrical distribution, the mean, mode and median all coincide C. Now let's understand the tests of skewness. There are three methods by which we can test the skewness of any frequency curve. The first one is the values of mean, median and mode do not coincide. And second is quartiles are not equidistant from the median. We all know that in any data set there are three quartiles. Quartiles divide the whole data in four equal parts, and we represent the quartiles from Q1, Q2 and Q3. So if there is skewness, quartiles are not equidistant from the median. Now come to third point. The frequency curve of the distribution is not a symmetrical bell-shaped curve, but it is stretched more to one side than to the other. So these are the three methods by which we test the skewness of any frequency distribution curve. So let's come to measures of skewness. We have two measures of skewness. First is absolute measures of skewness and second is relative measure of skewness. So first come to absolute measure of skewness. Absolute measure of skewness are used when we have data sets, when we have to compare uh, the data sets which have same statistical unit. Absolute measure of skewness cannot be used to compare two data sets which are expressed in different units. Absolute measure of skewness have statistical units. Now come to formulas. Skewness is equal to mean minus mode. Skewness is equal to mean minus median. So these two formulas are used as absolute measure of skewness. Skewness is positive if mean is greater than mode or median, and skewness is negative if the mean is less than mode or median. We have one another formula for skewness. Skewness is equal to Q3 plus Q1 minus 2Q2. Now come to relative measures of skewness. So what are relative measures of skewness? Relative measures of skewness are used when we have to compare two data sets which are expressed in different units. And relative measures of skewness are pure numbers. They don't have any statistical unit. So, in relative measures of skewness, we have four formulas. We have four methods. First is Karl-Pearson's coefficient of skewness. Second is Bowley's coefficient of skewness. Third is Cayley's coefficient of skewness. And fourth is moment measure of skewness. Now come to Karl-Pearson's coefficient of skewness. So the formula for Karl-Pearson's coefficient of skewness is equal to mean minus mode upon standard deviation. Or we have other formula SKP is equal to 3 mean minus median upon standard deviation. Karl-Pearson's coefficient of skewness varies between plus 3 and minus 3. So we can say that Karl-Pearson's coefficient of skewness is based upon the mean, mode and standard deviation. Now come to next measure of skewness. Second is Bowley's coefficient of skewness. Bowley's coefficient of skewness is based upon the quartiles. We know that in any data set there are three quartiles, and quartiles divides the complete data set in four equal parts. And second quartile, that means Q2, second quartile Q2 is always equal to the median, right? So the formula for Bowley's coefficient of skewness SKB is equal to Q3 plus Q1 minus 2Q2 upon Q3 minus Q1. Bowley's coefficient of skewness varies between plus 1 and minus 1. So students, always remember that second quartile, that means Q2 is equal to the median. That means if in any question we have to use median and median is not given, in that case we will use second quartile. And if second quartile is not given and median is given, then we use median on the place of second quartile. So Bowley's coefficient of skewness is based upon the quartiles. Now come to third relative measure of skewness, that is Cayley's coefficient of skewness. Cayley's coefficient of skewness is represented by SKK, and Cayley's coefficient of skewness are based upon the percentiles and deciles. We all know that percentiles divide the complete data set in 100 equal parts, and there are 99 percentiles which are represented by P1, P2, P3 and so on. And deciles divides the complete data set in 10 equal parts, and there are 9 deciles, and deciles are represented by D1, D2, D3 and so on. So now come to the formula of Cayley's coefficient of skewness. Cayley's coefficient of skewness is equal to P90 plus P10 minus 2Q2 upon P90 minus P10. This formula is based upon the percentiles. Now come to next formula of Cayley's coefficient of skewness. This is based upon the deciles, which is D9 plus D1 minus 2Q2 upon D9 minus D1. Cayley's coefficient of skewness varies between +1 and -1. So, in Cayley's coefficient of skewness, always remember that 50th percentile is equal to the median. Fifth decile is equal to the median. Right? Median, and median is equal to the second quartile. So always remember that median is equal to the second quartile, median is equal to the fifth decile, median is equal to the 50th percentile. Now come to fourth formula of skewness, that is moment measure of skewness. So let's come to Pearson's beta 1 coefficient. Pearson's beta 1 coefficient. Beta 1 is equal to mu 3 square upon mu 2 cube. Mu 3 square upon mu 2 cube, where mu 3 and mu 2 are the second moment and third moment of the mean. For symmetrical distribution, third moment about the mean, that means mu 3 is always 0. Hence beta 1 is equal to 0. That means if third moment, that means mu 3 is 0, in that case beta 1 will be equal to 0. The greater the value of beta 1, the more skewed is the distribution. So to understand the moment measure of skewness, to understand the Pearson's beta 1 coefficient, which is based upon the mu 3 square upon mu 2 cube, we should understand that what are the moments. What are the moments? So in next slide, we understand what are the moments. Moments describe the two very important characteristics of a frequency distribution, that are skewness and kurtosis. So the formula for calculating the moments is mu1 is equal to summation x minus x bar upon small n. In any frequency distribution, there could be four moments: first moment, second moment, third moment, and fourth moment. So the formula for first moment mu1 is equal to sigma x minus x bar upon small n. The formula for second moment mu2 is equal to sigma x minus x bar to the whole square upon small n. And second moment, that means mu2, is always equal to the variance. Variance means the square of the standard deviation. Now mu3 is equal to sigma x minus x bar to the cube upon small n. Now mu4 is equal to sigma x minus x bar raised to the power 4 upon small n. So mu3 and mu4, these two moments are used for calculation of skewness and kurtosis. Mu3 is used for calculation of skewness and mu4 is used for the calculation of kurtosis. Now let us understand some numerical problems. For a certain distribution, the mean is 200, mode is 195.2 and standard deviation is 16. Calculate Carl Pearson's coefficient of skewness of the distribution. So we are given mean is equal to 200, mode is equal to 195.2 and SD is 16. So first of all, write the formula for Carl Pearson's coefficient of skewness, that is mean minus mode upon SD. Put the values of mean, mode and SD and calculate. The answer will be zero point 0.3, and zero point 0.3 indicating only a very slightly amount of skewness to the right. Now, come to next question. Calculate Bowley's coefficient of skewness for a distribution having Q1 is equal to 30, Q2 is equal to 38 and Q3 is equal to 70. So, to solve this question, first write the formula for Bowley's coefficient of skewness. Bowley's coefficient of skewness is based upon the quartiles. So write the formula Q3 plus Q1 minus 2Q2 upon Q3 minus Q1. So put the values in this formula and calculate. The answer will be zero point 0.6. Again in another formula, calculate Cayley's coefficient of skewness from the following data. P10 is equal to 11.67, median is equal to 33.33, P90 is equal to 55, and we have to calculate Cayley's coefficient of skewness. First of all, write the formula for Cayley's coefficient of skewness. Cayley's coefficient of skewness is based upon the percentiles. So write the formula P90 plus P10 minus 2Q2 upon P90 minus P10. So put the values in this formula and calculate. The answer will be 0.0002. Thank you, class.